Okay, everyone. So today we're going to be doing a boiling point elevation colligative property problem. So first thing that I always do is read the problem. Calculate the boiling temperature for a solution that contains 0.325 moles of calcium phosphate dissolved into 240 grams of water. So the fact that it's giving me this KB value and boiling temperature, I know it's talking about boiling point elevation. So the very first thing that I'm going to do is write down the equation because that's how I'm going to be able to solve this problem. Okay, so here we have the full equation. Now, this is kind of where it's like, wait, where do I start? Where do I start? Let's define our solute and our solvent. So our solvent, right, is our liquid. So our solvent is water. It tells us right here that we have water. And then this is our solid, which must be our solute, calcium phosphate. Okay, so let's go now through these variables. Our I value, if we go back and think about what our I value is, it's our Van Hoff factor. What does our solute dissolve into when we put it in water? So maybe pause the video here and see if you can figure that one out. Okay, here we go. When we split this up in water, it's ionically bonded, so we know it's an ion that's going to dissolve in water. We're going to take our subscripts right here, and those are going to now be our coefficients. So our subscripts become our coefficients, right? And then these numbers also become the charge, but that charge really isn't important. Let's add up our coefficients and we get I equals 5. So we now know that for TB solution minus TB solvent, it's going to equal 5. Let's insert our KB that we're given, 0.512 degrees Celsius per molality. And then we still have that M value. So what is that M value again? That's molality. Okay, our molality is going to be something that we're going to have to write out like this. It's our moles of solute over our kilograms of solvent. Make sure you're not using molarity because that could get you messed up real quick. Okay, what is our molality? Well, what are the moles of our solute? Right here in the equation, we can see that it gives us our moles of solute right there. 0.325 moles. And then we also need to find the kilograms of our solvent, which is water. So right here, we're given grams, which is 240. So we need to put that into kilograms, which is going to be 0.240 kilograms. If you want the math for that, you can do it like this, 240 grams of water. When we're doing our conversion factors, on the bottom is what is right here. Those are going to match up. We know that there are 1,000 grams per 1 kilogram, and that's going to give us the value I just told you. So if you weren't sure how to convert grams to kilograms, there you go. So that is now our molality. If we solve that, we're going to get 1.35 molality. Okay, back to our equation. We have our boiling temperature of the solution. That's what we're trying to find. So we don't know what this is. But do we know this? The boiling temperature of our solvent. We do because it's water. So in problems with water, it's not going to tell you, but you just need to know that your boiling temperature is 100 degrees Celsius. That's just a standard. So I'm going to put in 100 degrees Celsius equals 5 times 0.512 times 1.35 molality. I know all my units are going to cancel out, and this is going to end up being 3.46 degrees Celsius. If you were to need to do this with sig figs, your I right here isn't going to be included in your sig figs because it's kind of like a constant. TB solution, what we're solving for, minus 100 degrees Celsius. Okay, we have to now add 100 degrees to both sides. So our TB solution is equal to 103.46. So that is going to be my final answer. And before I'm done, let's think about boiling point elevation. When we put in a solute into our solvent, our boiling temperature is elevated. So whatever you get here has to be more than the boiling temperature of water. 103 is greater than 100, so I know I'm okay. And that is how you do a boiling point elevation problem.